Hello everyone, my name is Veronica Cancio. I am the Pollution Mapping Citizen Science Project Coordinator, and today we're going to be talking about the Pollution Mapping Project. But before we do so, we need to give you a little more information about ORCA. So ORCA was founded in 2005 by Dr. Edie Witter, a bioluminescence expert and deep sea ocean explorer. And here at ORCA, the researchers and engineers work together to tackle conservation challenges, and they do this through the unique approach of innovative technologies and science-based conservation action. And the ways we carry out this approach are by these four means. We have our innovative technology, which encompasses our Kilroys, which are live, continuous monitoring stations throughout the Indian River Lagoon that tell us the health indicators of our waters. We have our applied science research, so this includes our Ecotoxicity Program and our One Health Fish Monitoring Project. And then we have education. We educate the community from kids all the way to adults, from elementary to high school, to adults from the community, all ages, all backgrounds, because it's very important that more people are aware of the challenges facing our Indian River Lagoon, the more likely they are to make a change. And then we have our citizen science, which are members from the community, some with no background in science at all. And we trained in our laboratory and field procedures. So they take part in actual real science. And it's a very unique way to have the community be a part of the solution. And we mainly focus our efforts on the Indian River Lagoon and the waterways connecting to it. And we're not sure if this still holds true, but the Indian River Lagoon used to be one of the most biodiverse estuaries in North America, home to over 2,000 animal species and 2,000 plant species. So not only is it a very important ecological aspect, but also it's very important for the economy, not only by the jobs it provides, but also tourism and the housing market. So you guys can see why it's so important to protect the Indian River Lagoon. And there are many challenges and many things affecting the Indian River Lagoon. It's not just one thing that we can point at. And here's a whole list of stressors that the Indian River Lagoon is facing. And at ORCA, we try to tackle all these issues through our projects. And today we're going to focus on our Pollution Mapping Citizen Science project, which actually came about from our Ecotoxicity Program. So this program basically created this map right here towards the right. So for the Ecotoxicity Program, we would go out at a specific time during a year and collect multiple samples at multiple sample sites. So here you can see this map, which is in between the two Barrow Beach bridges, North Bridge and South Bridge. And there's over 100 sample pointers or sample sites in this map, which allowed us to create what we call like a weather map, where blue in this case is low concentrations of nitrogen and red is high concentrations of nitrogen. So it's very unique because it gives us a snapshot at this time of what this site looks like. And it allows us to ask questions, right? Why are these little porks here so red? And why is this one up here to the top left blue? And Dr. Edie Witter actually realized that there's a golf course right there. And she wanted to figure out why this area had much lower concentration of nitrogen in comparison to these areas. And when she went over there and she started asking questions, she realized that they practice best management practices. So they pick up their grass clippings after mowing, limit the amount of fertilizers they use. So because of this map, we were able to identify that those best management practices were actually having an effect, a good effect on that water quality or specifically nitrogen in the water body. Another unique thing that came out of this map is Dr. Edie Witter presented this to the city of Vero, and it led to the fertilizer ban during specific months of the year. So although very impactful and leads to a lot of good things, it is only a snapshot at that time, which can limit our understanding of how those nutrients and how those pollutants are fluctuating throughout time. So this ecotoxicity program led to our pollution mapping, because in our pollution mapping, we actually do longitudinal monitoring. So instead of having a snapshot at that time, we're looking at sites throughout the year and throughout time. So we currently have 24 sampling sites throughout the integrated lagoon and connecting waterways. And again, we monitor 4 times a year. And what's really cool is that these 24 sites are actually monitored by our citizen scientists, or teams of citizen scientists that we've trained to conduct field and laboratory procedures. So and they do this once a month. So once in February, once in May, once in August, and once in November. And our first sites, PM1 and PM3, were added in 2020. And we've recently added more sites this year in Martin County. And again, what's so cool is that these citizen scientists are basically adopting these sites and monitoring them. And what they do actually is that they go out, right, in those months, and they conduct field and laboratory procedures. In the field, they go out and test for temperature, salinity, pH, dissolved oxygen, hydrogen sulfide. They also calculate muck depth and water depth. And with those field samples that they collect, those water samples and sediment samples they collect, they come back to the lab, either in our Vero Beach lab. And recently we've developed a mobile lab, so we can take the lab component to those sites that might be very far away, like those Martin County sites might be too far for Vero Beach. So we actually bring the lab portion to them, which is kind of cool. So once they're in the lab and the sediment specifically, they test for a relative toxicity. So how toxic is the site? We extract DNA. So we're currently looking at 4 different antibiotic resistant genes in the sediment. Particle analysis, so we test for the sizes of those particles. Microplastics, PFAS, which are also known as forever chemicals. PFAS stands for polyfluoroalkyl substances, and they stay in the environment forever, hence the name forever chemicals. They don't degrade. And some sources are non-stick coating for cookware, and you can find it in some plastics as well. So we're currently going to be looking at this in the sediment once a year. We also do nutrient analysis on pore water. Pore water is the water embedded in the sediment. So when they bring those sediment samples back, they put it in a centrifuge tube, they centrifuge it, spin it really fast, and separate the solids from the liquid, in this case pore water, and we test for nitrate, nitrite, ammonia, and phosphate in that pore water. We also test for herbicides, so glyphosate, diquat, atrazine, and once a year we send our samples to a contract lab, and they test for heavy metals, total organic carbon, and among other things. So that's all in the sediment. We also do analyses in the water column, and we look for alkalinity, herbicides, once again, acetaminophen and sucralose, which are human waste markers, so they can tell us where contamination might be coming from, so either septic or wastewater treatment. And we also do nutrient analysis, so the same nutrients, phosphate, ammonia, nitrate, nitrite, microplastics, and PFAS. So it's a lot of things that we gather, and it might seem overwhelming, but it is a team of citizen scientists, so you're not doing everything on your own. if you are interested in being part of this project. And also the words highlighted in blue are actually either done by an ORCA staff member or they're sent to a contract lab. So with everything that we gather, we are able to see and look at the data, right? So in this graph right here, we're looking at water column phosphate, water column nitrate, nitrite, and water column ammonia for sites 1 through 16 in August of 2021. And something that stands out is those blue bars, they, which are water column phosphate, seem to be highest among all the sites. So we are we can focus on phosphate and see how that compares through all those sites. And so right here, this is the graph just focusing on phosphate, water column phosphate. And we have some reference values. This orange line right here is the 50th percentile. So there was a study done throughout all bodies of water in Florida where they wanted to collect the concentration of nutrients, among other things, throughout all those bodies of water, so we can be able to compare those values to each other. So this is the 50th percentile, the red is the 90th percentile. So from those 16 sites, we have about 9 that are either on that 90th percentile or above it. So out of all the bodies of water in Florida, 9 out of our 16 sites in Indian Lagoon are on that 90th percentile, which is crazy. So this can lead us to ask where is this phosphate coming from, right? So there are many sources for phosphate. There is terrestrial runoff, groundwater, percolation, agriculture, among other things. So knowing this can help us, ask further questions and keep monitoring to see how it keeps changing, if not, and allows us to focus our efforts. This is just looking at a site or the 16 sites at a specific time, so August 2021, but we can also look at our data throughout time, or we can look at a site specifically throughout time. So here we're looking at site PM3 and site PM1. And 20 is the year, the letter is the month. So A is February, D is November. So we're looking at February from 2020 all the way to February of 2021. And for this site, you can see how phosphate kind of fluctuates depending on the time or the month of the year. So this is why it's so important to have a longitudinal data and longitudinal monitoring, because many things affect nutrients, and other things might change or fluctuate the amount of concentration that's in that, in this case, pore water. And by being able to monitor for long periods of time, we're able to see those patterns. And all this data and all these analyses and all the research that we do would not have happened without any of our citizen scientists. So it's so important that we have the community, backing us up and helping us, because it's a lot of work, and ORCA is a very small organization, but having those citizen scientists and having those committed members, members from the community being committed and passionate, allows us to, make a meaningful impact. So if you guys are interested, or any of you are interested in being a part of this project, or have any questions, just feel free to send me an email. My email is down here, down to the right. Yeah, if you want to be a part of this project and be a citizen scientist, just send me an email, and I can, find a team for you so you can be a part of, and also train you. So train you on those laboratory and field procedures. So thank you so much, and I hope you guys have a great morning, afternoon, evening, and I hope to see you all soon.